Redox, which is shorthand for reduction oxidation, is a type of chemical reaction classified by the net transfer of electrons. In this reaction, one molecule loses electrons, called oxidation, and the other molecule gains electrons, called reduction. To help you differentiate between the two, remember the phrase oil rig, which stands for oxidation is losing, reduction is gaining. The molecule that is oxidized is called the reducing agent because it reduces the other reactant. Similarly, the molecule that is reduced is called the oxidizing agent because it oxidizes the other molecule. Now that we have the terminologies sorted out, let's look at an example of a redox reaction, the formation of the mineral magnesium oxide. During the reaction, each magnesium atom loses 2 electrons. Thus, magnesium is oxidized. Each oxygen atom gains 2 electrons, thus oxygen is reduced. However, not all reactions are redox reactions. For example, the reaction of calcium oxide with carbon dioxide to form calcium carbonate is not a redox reaction. So how can we identify a redox reaction? To do this, we track the oxidation number of each element as it goes from reactant to product. The oxidation number is the hypothetical charge that an atom would have if its bonds to different elements were ionic, meaning that the electrons are assigned to the more electronegative atom. The sum of the oxidation numbers in a molecule equals its overall charge. Let's look back at magnesium oxide. It is a neutral compound, so the sum of the oxidation numbers for magnesium and oxygen equals 0. Magnesium can give 2 electrons, so its oxidation number is +2. Oxygen can accept 2 electrons, so its oxidation number is -2. How about the reaction? Pure neutral elemental compounds have an oxidation number of 0. Thus, both magnesium and oxygen start with oxidation numbers of 0. Both magnesium and oxygen's oxidation numbers changed during the reaction, so this is a redox reaction. Now, let's look at the calcium carbonate reaction we saw earlier. Both reactants are neutral, so the sum of the oxidation numbers for both compounds is 0. As we saw with magnesium oxide, calcium has an oxidation number of +2 and oxygen -2. Then the carbon in the carbon dioxide molecule has an oxidation number of +4 and each oxygen -2. How about the product? Calcium is +2 and carbon +4, just like in the reactants. Each oxygen is -2, totaling -6, with the net oxidation number 0. Since none of the oxidation numbers have changed, this is not a redox reaction. Now let's introduce the 4 types of redox reactions. The first is a single displacement reaction, where one atom displaces another. You'll see this in a thermite reaction, where one metal is reduced and the other metal is oxidized. The next type is a combustion reaction, which occurs between a fuel and oxidant to form oxidized products and heat. You see this in the lab during the combustion of methane with oxygen when using a Bunsen burner. The third is a synthesis reaction, where 2 reactants combine to form one product, like in the synthesis of ammonia, where nitrogen is combined with hydrogen to form ammonia. Finally, the 4th type is a decomposition reaction, where a reactant absorbs enough energy to break its bonds to form smaller compounds. This is what happens with fireworks, where potassium chlorate decomposes to potassium chloride and oxygen after heating. In this lab, you'll perform and identify various types of redox reactions that transform solid copper to copper oxide and then back again to solid copper.